Hi everyone, this is going to be a mini lecture on static and dynamic types. I will also be covering dynamic method selection and casting. Okay, so let's quickly dive in. We're going to start off by talking about static and dynamic types. Okay, so suppose that we have the following peach object, right? The static type of this peach object is A. Okay, the dynamic type of this peach object is B. So what exactly is the static type? What exactly is the dynamic type? I like to think about the static type as the type of the object, okay? I'll explain a little more of what I mean. Suppose that we have some sort of integer, let's say int a, right? We all know that the type of a is int, right? In the same light, we can say that the type of peach is a, and that refers to the static type of peach. The dynamic type is what the object actually is. What the object actually is. In this case, we see that peach actually is an instance of the B class. So its dynamic type is B, okay? And in this case, we can see that the static type may not be the same as the dynamic type, okay? Let's intuitively try to figure out whether peach is a valid instance. Let's try to also figure out whether radish is a valid instance, okay? So I think A and B is a bit confusing because this relationship isn't common in everyday life, so it's hard to build intuition. So let's think about another inheritance relationship. Let's say we have some class person, and then we have a class student that extends person, right? In the same light of creating peach, what we can do is create a student A that's equal, actually, my bad, we can create a person A that's equal to a new student, right? And this is perfectly legal. Intuitively, we know that the type of A is a person and a student is a person, so this is a valid declaration and definition, right? On the other hand, if we try creating a student B that's equal to a new person, this doesn't work intuitively because this person that we make may not be a student. So we can't say that its type is student, right? That's not true. Or that may not be true, okay? So that's a quick spiel on static and dynamic types. And with this in mind, let's dive in. And just to recap, radish doesn't exist. Okay, so here's the big chunk of this mini lecture, and we will be talking about dynamic method selection. So what is dynamic method selection? Dynamic method selection is answering this question. What method do I run? Okay, oftentimes you'll have a method call or a function call, and there's so many different methods that possibly could work, right? Looking at this example right here, if we have peach.f of peach, there's so many f methods, and we have no idea which one to choose, right? Well, lucky for us, dynamic method selection outlines very clear rules of which method we actually want to run. These rules are split into two parts. There's what happens during compile time and what happens during runtime. Okay, so first let's remember what is compile time, what is runtime. Very quick summary, and just this is more of just like intuition. Compile time, a Java compiler looks at all of the code and says, does everything look okay? Okay, during runtime, we actually run the code. That's like the split up between the two. Okay, so during compile time, what we're trying to do is answer the question of, does the method exist? Okay, that's like the question we're trying to answer. And I want to try to be a bit more specific. What we're going to do is look in the static type for the method signature that would suffice. Okay, if that method signature exists, then we're going to lock in on that method signature. So this may be confusing, so let's walk through an example of what all of this really means. In this peach.f peach, we know that the static type of peach is A. So what we're going to do is look in the static type class, right? Let's look in class A for a method signature that would suffice for the method call. Okay, we see here that this method signature would work because peach has static type A, right? And this f method takes in an object of static type A. So in this case, what we're going to do is we see that the signature exists. So we're going to lock in on that exact signature. So I like to use this terminology called lock in. What do I mean by lock in? What I mean is that eventually this peach.fpeach method call will call some function, right? When we lock in on a method signature, it means that we will execute this exact method signature, okay? We're not changing our mind. We will execute this exact method signature. It may not be the method in class A, it may be a method in some other class, but it has that exact method signature. That's what I like to think about at locking in, okay? So one other situation that arises during compile time is this process of inheritance. Okay, this is the idea that if we don't find what we're looking for in the current class, we don't give up. Instead, we keep looking in parent classes to see if that method exists, right? If we don't find a signature that works, we're going to throw a compile time error, right? We're going to say there's nobody that satisfies this method call, right? There's no methods, so compile time error, okay? Now let's dive into runtime, okay? During runtime, what we're going to do is ask ourselves the following question. Can we do better? Okay? In this example, recall that what we're doing is peach.f peach, right? So we know that peach is of static type A and dynamic type B, right? What I'm trying to get at is peach is actually an object of dynamic type B. So instead of choosing a method in class A, we would rather choose a method in class B because peach is actually part of class B, right? And during runtime, what we're going to do is we're going to ask ourselves, can we do better? Can we actually invoke the method that belongs to the dynamic type of the object, right? We would rather use the method in class B than class A for peach.fpeach, right? Okay, more precisely what's happening is that we're going to look in the class corresponding to the dynamic type for the exact signature that we locked in on during compile time, okay? In this case, recall that what we did during compile time is lock in on this method signature. So during runtime, what we're going to do is we're going to go to class B and ask ourselves, does this exact same method signature exist? If so, we would prefer to use that. It's better than what we had before because peach is actually an object of dynamic type B, okay? So in this case, what we will do is we will say, let's prefer to use this method, right? And then we will actually execute that function call. So this is a small other possibility is what happens if we have classes between this dynamic type and static type, okay? What we're going to do in this case is we're going to check if the exact same method signature that we locked in on during compile time exists in these intermediate classes. I'll quickly explain what I mean by that. So I'm going to quickly get rid of this just to create some space. So suppose that we have, let's say we have class A, class B, class C, and class D. Okay, and let's say that each of these extends its parent. Now let's go back to the original function call we had, like A or F that takes an object of static type A. And let's say that we also have it in class C. And finally, we have some sort of a peach. And now let's make peach of dynamic type D. Okay, and then let's do peach dot f peach. In this case, what will happen is during compile time, we will lock in on this method signature, right? During runtime, what we will do is we will look in the dynamic types class, which is D, for this exact method signature. But we will see nothing exists, but we can still do better than what we locked in on during compile time. More precisely, this method in class C is better than what we had during compile time. So what this check here is really saying is that if there's intermediate classes between the dynamic type and static type that are still better than what we locked in on during compile time, let's use those. Okay. Finally, if there aren't any better signatures around, that's totally okay. We're just going to use the method that we locked in on during compile time. Okay. So in that light, we know that, or it's helpful to think about dynamic or the runtime as answering the question, can we do better? If we can't do better, we just use what we locked in during compile time. If we can do better, then yay, it's a plus. Okay. So I'm going to walk through one more example here, and then we will move on to casting. Nice. So the next example I want to walk through is peach.f banana. Okay, so in peach.f banana, what's going to happen during compile time is we're going to look in class A, because that's the static type of peach, for a method that takes in an object of static type B, because banana has static type B, right? So what we're going to do is in class A, we see that there isn't an F method that takes in an object of static type B. Instead, there is an F method that takes in an object of type A, right? And that's going to work because B is a subclass of A. So this method signature, while it's not optimal, it'll still suffice. Okay, so during compile time, we will lock in on this method signature. Then during runtime, we're going to ask ourselves, can we do better? So what we do, we go to class B, and we see that the exact same method signature exists right here. Okay, and what's very important here is that we don't choose this method signature because during compile time, we locked in on this exact method signature. So during runtime, we have to choose that method signature in the dynamic types class if it exists, right? We can't change the method signature. That's not how Java works. Okay, so in this case, we won't choose this method, even though it's so-called better than this one, right? It's more specific. Okay, so that's like a quick downfall of maybe dynamic method selection. Okay, and to solve that or to address it, we can actually use casting. And let's dive into how that's going to work now. I'm going to bring this example. So first, what is casting? Casting temporarily changes the static type of the object or the variable. Okay, in this case, the problem from before was that peach was static type A. But what if peach was static type B? Then during compile time, we would look in this class and we would choose this method signature, which is the best one, right? In order to temporarily change the static type of a variable, we can do so using casting. How that looks is that we can cast the instance invoking the method call, like so. We can cast Peach to be of static type B. So what's actually going on here when we look at this cast? What we're doing is temporarily changing the static type of Peach. So for this function call and this function call only, Peach has a static type B and dynamic type B, right? Before it used to have static type A, now with this cast, it has static type B, right? That's pretty cool. So that's how casting works. We can also cast the parameter that's passed in. So a possibility is we can do peach dot f of b of peach, right? Right, this is totally okay. Right, another thing that we can do is that we can cast banana to be of class A, right? That's also a valid cast because banana would then have static type A and it would have dynamic type B. Cool. There's definitely like a bit more to casting in terms of like what errors could arise, but I think for now this is a good introduction and I recommend diving through problems 1 and 3 on the exam prep worksheet. That is all. Have a good one.